In this video, we'll discuss about representation of fractions as terminating decimals as well as non-terminating and repeating decimals. So the first question is, if a fraction is given, then whether it is possible to identify that the fraction has terminating decimal representation or non-terminating and repeating decimal representation. So let's see by taking some example. The first fraction we'll see is 5 by 8. If you carry out simple division process, we get divisor as 8 and 5 as the dividend. As 8 doesn't divide number 5, so we'll take decimal. Then 8 6 are 48. 8 2s are 16. Then 8 5s are 40. Now at this stage the remainder is 0, hence we got terminating representation of 5 by 8. So this is a case of terminating decimal representation. Now let's go one more step ahead and prime factorize the denominator of the fraction 5 by 8. So prime factorizing 8, we get 2 into 2 into 2, or in the exponent form we can write the denominator as 2 raised to 3. Now let's take another fraction 7 by 20. We'll carry out the actual division for 7 by 20. 20 is the divisor and 7 is the dividend. So we have to take the decimal. 20 3s are 60. 25s are 100. And 0 is the remainder. Hence we got terminating decimal representation for 7 by 20. Hence we can write 7 by 20 in the decimal form as 0.35. Now let's prime factorize the denominator 20. So we get 2 into 2, that is 4, into 5. So this is prime factorization of 20. In the exponent form, the prime factorization can be written as 2 raised to power 2 into 5 has power 1. Now 7 by 20 is again a terminating decimal. Let's take one more example, 8 by 25. We'll carry out actual division for 8 by 25. Here 25 is the divisor and 8 is the dividend. We have to take the decimal. 25 3s are 75. 5 is the remainder 50. So 25 2s are 50. Now at this stage we got 0 as the remainder. So we can write decimal representation of 8 by 25 as 0.32. As the remainder is 0, hence it is a terminating decimal. The denominator can be prime factorized as 5 into 5. So that will give us 25. In the exponent form, the denominator can be written as 8 divided by 5 to the power 2. Okay, so all these three cases are of terminating decimal representation. Now let's check some other fractions as well. 5 by 6. Now let's carry out the actual division. Here 6 is the divisor and 5 is the dividend. Now taking decimal, 6 8s are 48. Subtracting, we get 2 as the remainder. Then 6 3s are 18. So 20 minus 18 is 2. Again we got remainder as 2. Now this is never ending process. Hence we can write it as non-terminating by 3 dots. So 5 by 6 has decimal representation which is non-terminating. And if you see, it is also having repeating decimal. So 3 is repeating, hence it is non-terminating and repeating decimal. Now if the digits are repeating, then we can simply write it as 8 and we can put bar over repeating number. So this is how we represent the repeating decimal. Now let's prime factorize the denominator 6 as well. So prime factorization of 6 gives us 2 into 3. In the exponent form, the denominator will be 5 by 2 to the power 1 into 3 to the power 1. Now let's take one more example of non-terminating and repeating decimal. 4 by 15. Let's carry out the actual division for 4 by 15. Here 15 will be the divisor and 4 is the dividend. So we have to take the decimal. 15 twos are 30. 15 six are 90. 10 is the remainder. In the previous step, the remainder was 10 and in this step it is also 10. So the digits will repeat. So 15 6 are 90 again. Hence we get 10 as remainder again. So it is repeating and non-terminating. So the decimal value of 4 by 15 is 0.266 and so on. So we can write it as 0.26 and we'll put bar over a repeating 6 number. Now the denominator of 4 by 15 can be prime factorized as 3 into 5. In the exponent form, the denominator will be 4 by 3 to the power 1 into 5 to the power 1. So with this we got some fraction which are having terminating decimal representation and some fraction having non-terminating decimal representation. Now the question is whether it is possible to identify if a fraction has terminating decimal representation or non-terminating and repeating decimal representation. So let's see the fractions once again. Now in the first three cases, the prime factors of denominator are 2 or 5 or both 2 and 5. So for 5 by 8, the prime factor of denominator 8 is 2. For 7 by 20, the prime factor of denominator 20 is 2 and 5. And for 8 by 25, the prime factor of denominator is 5 only. So in all the three cases, either 2 is there or 5 is there or both are there as prime factors of denominator. Now for non-terminating and repeating decimals, if you see for 5 by 6, the denominator 6 has prime factors other than 2, that means 3. So 3 is extra over here, hence it will have non-terminating and repeating decimal representation. In the last case 4 by 15, the denominator 15 has prime factor other than 2 or 5 or both. So the other factor is 3, hence it will also have non-terminating decimal representation. Hence we can write in general for terminating decimal representation, for terminating decimal, the prime factors of denominator, the prime factors of the denominator must be 2 or 5 or both. So this is the condition for terminating decimal representation of a fraction. Now for non-terminating, for non-terminating and repeating decimal, for non-terminating and repeating decimal, prime factors prime factors contain factors other than 2 or 5. Now, this is how the definition of non-terminating and repeating decimal is there. So 5 by 6 has prime factor other than 2, that is 3, and 4 by 15 has prime factor of denominator other than 5, that is 3. So this way we can differentiate between terminating and non-terminating and repeating decimal by looking at the prime factors of the denominator. Now suppose we are having fraction as 9 by 12. Now 12 can be prime factorized into 2 into 6, 6 can be further prime factorized into 3. Now one can see there is prime factor other than 2, that is 3. But this is not the case of non-terminating decimal representation, because one has to have the fractions in the reduced form. That means we have to remove the common factors from the numerator and denominator. So 9 has prime factors as 3 into 3 divided by 2 into 2 into 3. So 3 and 3 will cancel out, and what remains is 3 by 2 into 2. Now here only the prime factors are 2, hence it will have a terminating decimal representation. Now to decide whether the fraction is terminating or non-terminating and repeating, first we have to remove the common factor from the numerator and denominator. Now let's revise what is meant by terminating decimal and non-terminating and repeating decimal. So in the first step we took one fraction, let's say x. Now the fraction can be represented as ratio of two integers. So p and q are two integers and all fractions are rational numbers. Then we prime factorize the denominator. Now here q is the denominator, so we prime factorize q, and then we checked whether the prime factorization of q is of the form 2 raised to n into 5 raised to m, because it may happen that 2 has power other than 1 and 5 has power other than 1. So if the prime factorization of q contains only 2 and 5 as prime factors, then that is a case of terminating decimal. And if the prime factors of q are not of the form 2 raised to n into 5 raised to m, that means the prime factorization of denominator contains some other prime factor. Now let's take a look at definition of terminating decimal. Let x is equal to p by q be a rational number. So this is the fraction such that the prime factorization of q, which is the denominator, is of the form 2 raised to n into 5 raised to m. That means the denominator has factor 2 and 5 with some exponent where n and m are non-negative integers. Then x has a decimal expansion which terminates. So the prime factorization of denominator must contain 2 and 5 as the prime factors with some exponent which are non-negative. Now let's take a look at definition of non-terminating and repeating decimal. Let x is equal to p by q be a rational number. So this is the fraction we are considering, such that the prime factorization of denominator q is not of the form 2 raised to n into 5 raised to m. That means the prime factor contains prime factors other than 2 and 5 where n and m are non-negative integers. Then x has a decimal expansion which is non-terminating and repeating.